Hi, everyone. Thank you so much for joining us today. My name is Keelan McDonald. I'm a product manager on the Vertex team focused on generative AI in Model Garden. And I'm joined today by my colleague Murari, and I'll let him introduce himself.
Hey, hi everyone. Thanks a lot for joining in. My name is Murari Amka, and I am one of the Gen AI ambassadors as part of Google Cloud India region. Happy to be the part of the session and looking forward for a great interaction with all of you. So let me quickly get started, right? I think today we are going to talk on to the very interesting topic, and the topic is like how we can try to use Model Garden as part of Vertex AI, right? Let me get quickly started with few, and this will be our agenda for today's, right? So what we'll be covering as part of today's discussion is maybe we'll try to cover a high level overview onto the Model Garden, okay, which will be like approximately 7 to 10 minutes, and then followed by a demo, right? So we recently have launched few interesting and very, what will say, powerful LLM models. Okay, so we'll be trying to demo that to you, and then maybe try to, what will say, see how it is solving the actual use cases and industry problem. Followed by that, one of the very important thing which generally is a ask, right, from the industry, that okay, we have a lot of LLM models, how to manage it, right? Whether it's follow the same methodology of MLOps, or how we basically can go ahead and deploy our LLM model. So that would be our point number three in today's agenda. And as this is the live session, I request everyone and encourage to go ahead and put your questions, and we'll be happy to take all those questions during our sessions in the end, right? And we will also going to share. So maybe once we complete everything, right? Maybe in order to enable every one of you who have joined, we will also going to share a few of the resources which will definitely will going to help you in order to pick these learnings. Cool. So let's get started, right? So our first, let me get started with this, right? So we know that Google is an AI company, right? And all the LLM. So our the Google LLM journey started back in 2017, right? So the first LLM model, I think most of you must be knowing, right, is the Transformer, which was given by Google, right? So though there are multiple LLM models which are there into the market, but Google was father of, I would say, LLM, who started with the Transformer, right? And that's where I would say this is the foundation for all the LLM model which you will see into the market, right? So we started with Transformer, then we also have come up with Bird, and then T5, Lambda, then AlphaFold, Palm. So you must have seen, maybe we have come up with Palm and Bard, right? So these are the two models which you must have seen is being used widely, right? On top of that, if you will see, right, one of the very differentiating factor which we bring onto the table is the responsible AI, right? Though though these, what will say, foundational models, or though these LLM models are very very powerful, but putting a layer of responsibility or responsible AI is very important on those LLM model, and that's where Google differentiate on that particular part, right? All these models comes maybe with a deep research from our, what will say, sister concern company, which is nothing but a deep mind, right? So this is the overall journey which I just wanted to show and bring in front of you. Though we are continue to innovate, and there are few other models which are into the pipeline, which you will see Google will launch pretty soon, right? So this is our journey so far. Now let's see, right? Though we are talking about the model garden, and I will maybe try to talk about that, what is model garden, but what we believe onto the wide range of the model, right? uh, I know there are multiple, what will say, models which are available, which is like one model which is trying to solve everything, but what we believe onto the wide range of different models, right? And if you'll see over here, as part of Google, when we talk about first party model which is offered by Google, we have like a six different foundational model which we try to serve or solve for different use cases, right? We start with Palm for text, which is very specific model for language, right? So in case you want to go ahead and do something around language, like try to generate something onto the language side of it, or try to summarize, or maybe try to, what will say, generate an email and all those type of textual what will say requirement. That's where we have the foundational model, which is nothing but palm for text, right? Similarly, we have another foundational model which is palm for chat, which is primarily used for doing the multi-turn conversational, right? So maybe the uniqueness of this model, which is palm for text, is it preserves the context of your conversation, so that it can, maybe rather than you ask the same questions again and giving the context once again, it understand that context and try to basically help you and guide you with that conversation, right? The third foundational model which we offer is imaging, which is primarily text to image. So you can give a plain English, what will say, prompt to this particular model, and then you can get the image generated out of it, right? Again, as part of this image gen, we have multiple different functionality which we offer, right? And those are nothing but the edit image, okay, and visual Q&A, and then maybe try to do the watermarking and others, right? So there are multiple important, what will say, features also which we give, which we provide out of this particular model, which is text to image, right? Yeah, and then what will say, the fourth foundational model is nothing but the embedding is very important when we talk about unstructured data, right? And then we want to extract the semantic information from, consider those unstructured data, which could be images, PDF, and others, right? And that's where we offer a fourth foundational model, which is nothing but embedding APIs for text and image, which can help you to extract the information and semantic information on top of this unstructured data. The fifth one is chirp, right, which is primarily around the text to speech, right? Maybe I know maybe most of the folks will have a question that you already had speech to text API, text to speech API, but why chirp, right? Chirp is powered by LLM, which gives you a lot more powerful accuracy. And then maybe if you have not tried, I request everyone to try that, to find out that how it differs from the speech to text or text to speech model which we had. And last but not the least, which is I think interest for everyone who joined this particular call or particular meeting, right? Which is Cody, right? We all are developer, we all are technical people, right? And we love to try to find the shortcuts, and that's where Cody will allow you to generate the code out of the box. Maybe you can just give a simple prompt and it can generate the code for different programming languages, right? So these are the six foundational model which is offered by Google, and all these are nothing but the first party model, right? Let's know now, go ahead and try to see that, okay, what is Model Garden, right? And as part of Model Garden, if you see, right, it's nothing but what will say is a bouquet of the all the LLM models, right? So when I say bouquet, we integrated the Google owned model, which is the first party models, then all the open source model, and then the partner model, right? So it try to give you the customization and experimentation with multiple different models and API, which are not only just Google provided, but maybe a open source and the third party provider, right? So let's just try to understand, right, how does it works, right? If you'll see, right, maybe for solving all the different use cases, right? Maybe not just what will say the foundational model will work, right? Because the foundational model, you have maybe a very few options of doing the fine tuning, or maybe I would say the few sorts learning or zero sorts learning, or maybe a very specific, what will say, uh, if you're looking for a very specific set of use case or very specific set of problem to solve, right? And that is where what you want to do is you want to go ahead and fine tune the model, right? So in order to do that fine tuning the model, what you do is you try to do the transfer learning type of thing, right? You want to go ahead and do the adaptation, right? You want to go ahead and do the distillation, right? So all those techniques you want to apply on top of your data, so that maybe you create a what will say adapter layer on top of the foundational layer or foundational model. And that's where this model garden will help you, right? So model garden will help you try to maybe go ahead and customize the foundational model based on your need, right? And if you'll see right into this slide, under Model Garden, you will see the models which are coming from Google, which is the first party model which I talked about, which are nothing but text bison, code bison, chat bison, image gen, etc. And we have open source model, right? So we are very happy to say that we have Llama and a couple of other models like Stable Diffusions. Then we have Falcon and other models as a part of open source community, which is hosted into the Model Garden. And then the partner provided model, right? So you'll see, and we host maybe more than 100 model as a part of Model Garden, right? And let me quickly go to the next slide so that maybe you understand that what we are trying to talk about, right? We already had a platform, and I hope most of you are aware about that. So we already had a platform called Vertex AI, right? And what we did, right, since all these things are maybe linked to the AI side of it, the Model Garden, or I would say the what will say generative AI studio, and everything is packaged towards Vertex AI. Vertex AI was a platform or is a platform which allows you to do end-to-end ML activities, starting from what will say the EDA to model tuning to model deployment to feature store, or maybe to the consuming the model as an endpoint, as an inference, right? So basically Vertex A was already there, which was providing you maybe the end-to-end ML lifecycle development. If you'll see, right, with Model Garden, basically, and you see the blue one, which is nothing but the ML platform, which was already existing as a part of Vertex A, where you are doing the experimentation, training, testing, and model deployment. But the green part is something which is related to the Gen AI in this current slide, right? So as part of the generative AI, if you'll see the green boxes, right, we started with Model Garden within the same Vertex AI platform, and on top of that, if you'll see, we talked about a foundational model, and then you can go ahead and tune that model, and that's where the adapter layer comes into the picture, which I was talking about. So what we are trying to say in this particular slide is that Vertex AI will allow you to go ahead and use the foundational model as well as go and customize based on to your need, right? So you have both the options available for you as part of Vertex AI platform. Let's see, right? As I said, right, we are happy to say and share that, right? I think today also we have introduced few other models as a part of Model Garden, right? But as of now, we have more than 100 plus model, right, which are available as part of the open model ecosystems, right? All those could be the first party model, could be the partner model, could be the OSS, which is the open source model. And as you know, right, Google is the promoter of open source community, so we are happy to bring most of the open source model also, if you want, right, or anyone, you will see that there are multiple open source models also are hosted as a part of Model Garden ecosystem. Okay, I just took the name of few of the interesting model, but these are the model partners which we have. If you can see, right, it is Anthropic. Then we have Mid Journey also is one of the what platform which is hosted as a part of the partner ecosystem which we had, right? We have Runway, we have Cohere, right? So there are multiple model which is coming from the partner also, right? Llama is coming from Meta, which you can see as one of the very powerful model of LLM, which is primarily used for solving the summarization use case, right? So let's try to understand, right, that how basically we go ahead and tune the model to fit our use cases, right? And this is very important, right? So we say that maybe not every size will fit to everyone, right? And that's where we need to tweak maybe, or we need to do the customization like we do it for our cloth, right? For the models, right? And in order to do that, right, what we try to provide and what we offer is a different variety and wide range of tuning capability across our foundational model. So let's talk about the image gen, Palm, Cody, and open source model, how we can go ahead and try to tune based on to your, what will say, the need which you have, right? Because it may not be the only the common problem which you want to solve, right? Most of the time when we talk to the enterprise and when I talk to my customer, they say that, Murari, I'm looking for the problem to solve on my data set, and this is what the problem I'm trying to solve, and that is where the fine tuning or tuning the model comes into the picture, right? So what we bought, right, and these are the four, what will say, areas where you can quickly go ahead and tune the model. So you can try to improve the model performance with a very small set of tuned data, what we call it as a adapter tuning, right? So you give a JSON file in that you have an input and output, and within that input and output you can quickly go ahead and basically try to give 100 type of example, and then based on that model can go ahead and create an adapter which is a weighted which is a, what to say, weight type of model which will reside into your ecosystem or into your GCP perimeter, and then improve the performance of that model, right? So basically what I'm trying to do is we are trying to create an adapter layer on top of the foundational layer based onto your data set so that the performance can be improved. The second part, which is I'm very, what will say, happy and excited to say that it's again one of the very, what will say, unique composition which Google brings onto the table, which is nothing but RLHF, which is nothing but reinforcement learning from human feedback. So if you feel that the output which is getting generated from the LLM model is not accurate, you have the option to go ahead and do the thumbs up or thumbs down, and based on that it goes and optimize the model performance. Okay, so as a user you have the option to, what will say, rate the output of the model which is getting generated, and based on that the model performance will go and, what will say, increase, right? So it takes the human feedback into the loop and try to optimize the performance of the model, right? The third option is generate image customized to your business, right? So maybe image generation is one of the very unique proposition which maybe is very important when we talk about LLM, right? So sometimes what you are trying to do when you are trying to generate that image is you are very specifically looking for object tuning, right? And that's where you want to basically use or try to customize the model in order to generate a very specific to your product or logos, right? So maybe I'm working for one of the automotive company and they are very specifically looking for to, what will say, create a prototype of some vehicle, right? And that is where the object tuning part is very important when I'm talking about the image and model, right? The second thing is the style tuning, right? So if you're working with, maybe consider e-commerce company or a retail company, right? That's where maybe you are trying to basically align that image for some unique aesthetic, right? So you want to maybe put a collar onto the t-shirt, right? That could be a very unique aesthetic you are looking for in order to generate that image, right? And that is where the customization part of image gen comes, which gives you the ability to tune the model, right? And then maybe the fourth option, which basically allow you to tune the model, is nothing but a predictive AI on your data, where you can go ahead and use auto ML in order to, what will say, train your data and solve your business need, right? So these are the four options which you see in front of your screen, which allows you to tune the model in order to fit your use case. As I said, right, not every time foundational model can help you or solve your business use case, but most of the time you might need to go ahead and tune or customize that model in order to get the right output from that LLMs, right? Quickly, when we talk about the AI project, right, and I hope maybe whoever has joined, right, I can see most of you, like I can see there are so many people who have joined this particular call, right? And you must have done some practice or some exercise or maybe some POC or some development as of now. If not, maybe we'll be sharing some learning material also. I request maybe everyone to go there and try to maybe pick some use cases. But in order to start your AI project, right, generally it is categorized into six part, right? And if you can see, right, all those six part, maybe you can start with few of the use cases, which is primarily the simple one, which is language image, can be easily done by the pre-trained model, right? And for some specific use case which is around the speech, tabular, and other data, you might need to go ahead and do the multiple tuning level, right? And maybe for some, again, could be a mid-level type of complexity, right? So it's very important to identify the right AI use cases and then pick the right model or right, what will say, techniques in order to go ahead and solve that use case, right? Again, let's maybe, and this is my last slide, right? So what we are talking about is the model garden, right? And model garden basically is for Gen AI developer, right? What unique proposition or unique property it brings onto the table is state of art, right? As I said, and I'm keep repeating that it's not just the first party model, but it is a composition of first party model, open source model, and the partner model, right? It is built via the Google research team and have basically, you have seen, right, the father of all the model is nothing but a transformer, right? Which is given by Google. So what we have done maybe as a part of this particular model garden is that we have given the continuous innovation and the continuous learning which Google research team have. The second proposition which we bring onto the table with this model garden is end-to-end governance, right? So something like prompt tuning, prompting, distillation, right? Customizing the LLM can be easily done, right? MLOps, which is when we talk about the large language model, right? We want to bring the capability of, we'll say, the end-to-end setting of the pipeline. So that's again possible with the Vertex AI Model Garden. And the very important point is enterprise readiness, right? So you want to go ahead and secure your data, data privacy, data governance. You want to control and try to basically scale this particular model. And that is where I'm very proud to say that all these models which is offered by Google are enterprise ready, right? So these are the three proposition, unique proposition which we bring onto the table with Vertex AI Model Garden, right? I'm happy to take any questions. If you have any question, feel free to put it onto the chat and we'll be able to take it into the end, right? Over to you, Kellen.
All right, thank you, Mari. So I'm just going to take you through a demo here of what we mean by Model Garden and some of the examples that Mari brought up. So we're really happy that we've been able to partner with Meta most recently to launch their Llama family of models in Model Garden. And so this was announced a few months ago. We have several variations, and I'll kind of walk you through some of those, but it includes the flagship model Llama 2 as well as Code Llama. And really what we're offering on Vertex and in Model Garden is the option to have a single click deployment experience, tune with your data, as Mari was just showing you, select the model size that makes sense for your budget and your use case needs, and then also improve the output of the model, improve the safety of your users by adding content moderation and other tuning options all on top of that. And so really the driving concern here is one, we want to offer you a state-of-the-art model on Vertex that's super easy to deploy. And two, we want to offer it to you in an environment where you can really have a maximum amount of control. So just briefly, I'm going to go over in the next 10 minutes here what we have in terms of the Llama family, how you can get started, what it's like to actually deploy and serve these models, and then some of the tuning options that you can actually access either through Vertex Workbench or actually directly in a Colab notebook if you're familiar with that environment. So let's jump right in here in a minute. And so really, if you're already familiar with Vertex, a lot of these workflows should look very familiar. There's nothing new per se about how to deploy a model. What we're really offering through Model Garden is just the convenience to actually grab the container, put it directly on Workbench and in the notebook. So this is just a quick table to show you all the options that we have for Llama 2 currently. You'll see we have 3 different sizes that Meta's offered us, as well as a chat fine-tuned version. So if you're building a chat bot, for example, those fine-tuned chat versions have been additionally trained on chat data examples and are really good at use cases around chat and sort of conversational type experiences that you might build on top of your LLMs. And so again, there's 6 different total Llama 2 models available in addition to Code Llama. And it's really, we encourage you to test and kind of decide what's best for you. Obviously, the bigger models are going to require a little bit more hardware, a little bit more work to get going, but they might be appropriate if you have a little bit more robust of a use case. If you have a very narrow use case, a very kind of narrow chatbot type use case, the 7B chat might be perfectly good for your use case. And it's also going to be a lot more efficient in terms of serving costs and hardware and all that kind of stuff. So again, really, this is just one example. What I want to stress to you is what I'm going to show you in terms of workflow here can be replicated across all of our open source and first-party models. So to Murari's question in the previous slide, when would you actually want to do tuning in general? And tuning is really for use cases when you have a very specific type of output that you want. So you want a certain type of tone from your LLM, you want a certain type of domain knowledge. And so parameter efficient tuning, which we're going to show you, reinforcement learning from human feedback, these are all really great and relatively low cost, low effort deployment options around different ways to tune your model. So again, you're not creating a brand new model, you're just creating adapter layers on top, which are really kind of efficient for you to serve. All right, so with all that, how are you going to get started? So if you go into Model Garden, and we'll do a click out of this in just a minute, you're actually going to find a couple different model cards for Llama. Right now, what you're seeing is just kind of a quick deep dive into what that experience actually looks like. So you're going to get an overview, you're going to get a little bit of detail on the use cases, you're going to get some kind of legalese around the actual terms that you're going to accept when you use an open source model. And so this is going to look a little bit different from model to model, but you're just going to kind of scroll through, and that's going to help you evaluate whether this model is right for your use case. What you're seeing up here are two different deployment options. The button on the left is going to take you into Vertex Workbench, where you can deploy directly through Workbench. And obviously, the button on the right that says Open Notebook is actually going to take you straight into Colab. So if I click the button on the left, which the workflow is showing you here, I'm going to be in Workbench. And really what I'm doing right here is saving the model, giving it a few parameters, giving it a name, indicating some preferences around how I want to manage that. And so that model is going to end up right here in the model registry. And so you can see here that whole workflow, even though this is a time-lapse video, that whole workflow really only takes about 2 minutes to complete. The only step that takes a little bit longer is actually deploying the model and deploying to the endpoint. So what the endpoint is really going to do is just give you a nice way to easily do inference on it. There's a few different hardware recommendations based on the size of the model that you're serving. These recommendations also apply up and down kind of the different sizes of OSS models that we offer in Model Garden. Our advice to you as you deploy these is to experiment a little bit what works for you with your budget, with your kind of latency needs, all that kind of stuff. So taking a step back, once you've sort of made the decision about what you want to deploy, the hardware that you want, the budget that you have for your project, you can sort of take a step back here and go back into the notebook experience. And so really the notebook is going to make it easy for you to just get started testing with some inference, with some prompt examples. And the great thing about the notebook environment is that, as you'll see here in a minute, it's super easy to stand up and stand down. So I'm going to actually take a step back here to a broader view of Model Garden here. If you're coming in through Vertex, if you're already in the Google Cloud, this is where actually you're going to start. And you can see here there's a nav on the left that's going to help you kind of narrow down what models that you want by task, modality, other things. So really, this is a discovery platform. These models are here for you to evaluate, for you to choose. So assuming that we're kind of going back in and using Llama, we have a test, presumably we have some sort of use case that requires a text model. As a developer, you're going to kind of go through and deep dive into the model card, compare maybe this model card with another model card to decide which model is going to make the most sense for you. And again, there's really no right answer, which model is the very best. Different models work better for different use cases. Again, that's why we're not just offering first-party models. We believe that model variety is actually the most important thing for developers. There's no one right model for everything. And so really giving you that toolkit is our priority here. So what's happening right now is I'm just deploying the model again through the Colab Enterprise experience. So if you're not familiar with Colab, this is our notebook environment. It's just a super easy way to get started writing getting these models set up in code. You'll see here if you open this Colab example, and this works very similarly for other models in Model Garden, that you're going to see a bunch of metadata that our team has set up for you here. Gives you a little bit of information about the model, some of the costs that you might incur. And then you're really just going to click through the cells to get the model stood up. And I'll highlight a few areas where you're going to have to, insert a little bit of metadata about your account, the different buckets that you might be sending information to. But what I want to stress here is that I'm not writing any of this code, or you as a developer would not be writing any of this code. The only step at which you're really going to have to make any modifications are just, again, passing in your credentials and making any modifications to the test prompt. So this is a super quick process. I'm going to show you a little bit of a time-lapse view again, just to kind of get through that deployment step, which does take about 20 to 30 minutes. But running all the cells in the notebook takes a very trivial amount of time. And so what you're seeing here is I'm just selecting which base model I want. So again, we mentioned this earlier, but there's actually 6 different types of Llama. The great thing again about this notebook too is that you can test different versions. You might want to start with the cheapest, smallest version and see if that works. If it's not quite up to the performance standards that you need, maybe you upgrade to a bigger model. Again, we always recommend here that you start with probably the smallest minimum model that you can get away with, because it's going to be a lot more cost efficient, and you can always scale up later. Again, this is the beauty of Model Garden and these notebook driven deployment methods, which is you're not stuck with one model. You have a lot of optionality. You can swap out these training data sets that we're showing you here and retrain those adapter layers on different models. So again, what you're seeing here actually in the model or in the notebook right now is actually the training data set. In this example, we're actually just pointing at a little data set on Hugging Face. You could also find data on Kaggle. You could use your own data. But again, emphasizing here that all I'm doing is pointing to a path where my data is. I'm not writing this code, it already exists. So it's just super easy to do that additional tuning layer on top of the model if I know what sort of output I want to do. And so as you kind of scroll through the notebook, you're going to see more additional training layers. Right now, this is really the evaluation layer that you can get on top of the tuning or the PEFT tuning, prompt tuning. As we go down further, you're going to see examples of how to insert reinforcement learning from human feedback. So these are going to be data samples that have been rated by human reviewers. So you can provide that type of data as well. And again, it's super easy to just test different options, right? So sometimes parameter efficient tuning, adapter tuning is perfectly sufficient. It's probably going to be the lowest barrier to entry. Sometimes you do need that human feedback to really refine examples and get a more precise response from the model. But as you can see with the notebook, it's really easy to just point to different data samples and try to build up those adapter layers and get different examples. So I would really encourage you to hop over to Model Garden and explore this on your own. Like I said, this is totally GA. Everybody can access these notebooks and spin up these models at any time. And you can see down here, especially if you're wondering, like, how do I do this? How much does this cost? The notebook offers a lot of detail in terms of the guidance about the cost that you can expect to deploy, to serve, and then ultimately to run inference. And down here, just kind of walking through, this is all from TensorBoard, but this is just showing you the different workflows around the model, where the adapter layers are coming, how the inference is coming in. So this is super helpful, especially as you might be in a prototyping phase as you start this, but as you think ahead to how do I actually get this in production, these types of reference architectures can really get you in the mindset of understanding that. And then finally, we've reached the end of our notebook here. You'll see it's called cleaning up. And so the great thing about this is that's kind of the decision point. So you can decide, yes, this model works, or I'm going to go back and make some changes and redeploy it. Or you can decide, you know what, this isn't the model for me. I'm going to spin it down. I'm going to get those machines back and try a different model. So it's super easy to get started, super easy to test, super easy ultimately to compare all these models, and then wind up or wind down whatever you do or don't need. So would definitely encourage you to take this for a spin yourself, but hopefully that's given you some orientation about how you can get started with these models. And I'll pass it back to Murari now to talk a little bit about MLOps and how you can kind of think about productionizing these in that model that makes the most sense for your use case.
Cool. Thanks, Kylan. Looks very interesting, at least, right? And as you rightly said, right, there's no right model, and maybe it completely depends on your use case, right? And there are multiple options available, right? And then maybe you can quickly try and find out that which model is suitable and giving you the best accuracy or best evaluation, right? So let's go into maybe the next topic, right? And the next topic primarily is around managing your model with MLOps, right? One of the question which I see from my customer at least is that, I have set up MLOps, right, for my entire AI ML lifecycle. Now with LLM coming up, right, can I discard all the MLOps which I have created? And that's where the worry I can see from the customer, right? But the answer here is no, you don't have to go ahead and discard everything. Rather, it's just an additional, what is a few steps which you need to bring into your MLOps pipeline and try to make it, what will say, LLM ops, right? And that is a very what will say, buzzword which is going on, that if I want to go ahead and use the LLM model, right, which is maybe trying to customize and fine tune for my need, how I can set up that LLM ops pipeline. And that is what the next topic which we are going to talk about, right? I think this is one of the standard, or sorry, what is the paper which we have come up with. It's long back in 2021 or 2020 which we have come up with, right? And again, I encourage everyone to go ahead and understand that what is MLOps, maybe just to set the little background, right? Just maybe to revise it, that what is MLOps, right? It's nothing but a set of standard processes and capability for building, deploying, and operationalizing your ML system, which are rapidly and reliably, right? So these are the two very important words, that you want to deploy your LLM words at a very fast pace and also try to make it reliable, right? And that is where the concept of MLOps came. And I encourage, if you have not gone through this particular what is it paper, I just request, maybe if you can spend some time, you can easily find it out, right? What we have seen so far, right? And this is, as I said, the common question which I see from my customer, that can I throw out my existing MLOps? No, you don't need to be, right? And that's where maybe I'm going to try to cover that. What are the new addition or new features or you can try to bring on top of MLOps, so that it can serve the LLM ops requirement, right? And these are the 5 points which I have listed, and my entire discussion maybe would be based on this, right? So the first thing is, we are talking about LLM, right? And why LLM is little different than that, what will say, traditional AI. And maybe I'm happy to say that now the AI become traditional and LLM is modern, right? So again, this is the world which we are into, right? So again, in traditional AI, you go and solve a very specific customized based problem, right? Though LLM is primarily meant for, what will say, generic type of use case. And you means, as an individual user, you are not going ahead and creating the LLM, right? Basically the LLM is something which is already created as a foundational model, and then you are trying to maybe tune it or create adapter layer on top of that, right? And that is where, since we are talking about a huge model, which is like billions and millions of tokens, right, which has been fed in order to tune this or train this model, it needs extensive compute, right? And that is one of the differentiator which you will see compared to ML ops, right? So it's like a multitask model which has a prompting and needs a huge AI infrastructure. The second thing, which is unique in LLM ops, is the customization. So you basically not going ahead and basically doing the hyper parameterization tuning every time, which we generally do with our AI model. Rather, you are trying to tune that model and customize based on your curated data set, right? The third unique difference which you will see is artifacts, right? So with LLM coming up, there are few new artifacts which will come into the picture, right? Something like embedding, something like prompts, something like adapter layer, right? And again, we will see that how it can be, we'll say, managed and integrated into current ML ops platform, right? Then one of my customer was asking that how I can evaluate LLM, right? How I can try to find out that which LLM is better, this one or this one. And that is where the evaluation and monitoring comes into the picture, for the output which is getting generated from this LLM. And we are happy to say that we have launched three different techniques, right? And again, I'm going to talk about in the detail, in order to evaluate that which model to go ahead with and which model is performing well, right? And then finally, last but not the least, right? Every customer or everyone has a huge data set, right? So we are talking about the enterprise customer, where we have the data warehouse, data lake, which are already built, right? Now customer want to integrate that data and try to take the actions on top of that data set, right? May not be just a common problem that generate an email. Rather, they want to integrate with their data set and then get the insights, and that is where the connecting with enterprise comes. So these are the five very important points which maybe is on top of ML ops, which will try to make it as the LLM ops, right? So let's understand that, right, how we can try to solve, what will say, those five additional points, right? So we have seen this, and maybe most of the organizations will follow some similar type of pattern. May not be exactly, but yeah, there could be few here and there, but this is a standard MLOps framework. Maybe we are calling it for yesterday year, but yeah, it's a platform, or it's a, what will say, pipeline, or it's an ecosystem which basically allows you to do the ML ops end to end, right? So it starts with experiment. Then you have a, what will say, orchestration, where you try to train the model. Once the model is trained, you go ahead and deploy it and consume it as an endpoint and try to generate inferences or prediction from that model, right? So this is what I think everyone is very familiar with, which is nothing but the ML ops framework pipeline, right? Now let's see. And again, you will see maybe talking, or maybe you will see that in my slides, right, I have added some blue color, right? And this blue color indicates that additional feature or additional functionality which we are trying to, and there's some gray, or maybe which we have, what else I try to take out. But the the blue piece into the slide is something which is the addition from LLM ops perspective, right? So instead of experiment, right, as Kellen mentioned, right, that we have multiple different models. So you might need to go ahead and do a discovery that in order to solve my use case, which model is suitable. And that is where the discovery parts comes into the picture. So you go ahead and try to find out which one is the right model for your use case, and hence the discovery. And if you'll see, there's a blue line directly from discovery to the prompt or the predict, right? So if you are able to discover the right model for you, you do not have to go for a complete orchestration. You directly can use that model if you're able to discover for your, we'll say, use case by applying the right prompt, right? And this is what maybe we are calling it as a models and prompting, right? So here you don't have to go at very extensive for fine tuning and others. But in case maybe you are not able to discover it, and again, in order to do that, uh, we are talking about again the model garden platform. So within Vertex AI Model Garden platform, we have multiple different pre-trained model. I was very, what will say, I was talking to one of my customer and they said, I want to basically go ahead and try to do this classifications of the IT ticket, right? Which is a very common problem, right? So maybe I am getting a lot of, what will say, IT support ticket, and since I am not sure that which, and maybe it's a mandatory field. One of the field is mandatory, that what type of ticket it is, which team this it will going to assign it with, right? It could be software, hardware, it could be operating system, etc., right? So since it's a mandatory field, the user go ahead and select any option there, and then if the options, or maybe if the category is not correct, it goes and gets assigned to the different team, and it takes a lot of time. I'm amazed to say that as part of Model Garden, as part of Generative AI Studio, all those, some I will say, classifications models are readily available for you. Okay, you don't have to go and maybe develop it from the scratch. Okay, and those, what I'll say, common use cases which you want to solve, right, like summarization, occupancy analysis, classifications, okay, customer, what is the sentiment analysis, and all those prompts are readily available for you. You don't have to do anything, directly go ahead and consume. So what I'm trying to say, with the help of Vertex AI Model Garden platform, you have multiple different pre-trained model and multiple different pre-trained prompting which are available for you, which can be consumed directly, right? Going next, right, once you have basically done the discovery, right, it may possible that after doing the discovery, you analyze that I need to go ahead and do certain customization, right? And then that's where, if you'll see the boxes which came into the blue again, is tune and distill, right? So you understood that, maybe the discovery or the, what will say, foundational model is not working as is. Now let's go ahead and try to do some part of tuning of that model, and hence the orchestration box, which was like grayed out into the previous slide, came into the picture. And what you're trying to do here is tuning of the model, and trying to basically do the distill part of it also, right? You will also see there's something called as, what I'll say, artifacts, curated data and artifacts also came into the picture, right? And in order to do that, right, what are the different techniques which we have, right? So how we do the customization, and tuning, customization with tuning, and how we can create a curated data, right? I think I have spoken about it, but one of the image which you see over here is again created by our image gen model, where maybe a dog is trying to create the prompts, trying to, what will say, update the prompts, trying to refine the prompts, and then it is saying that, oh, it's, I have been like a prompting for the day, right? And his dog is completely exhausted now, right? So in order to tune the model, right, we have two techniques, right? You can go ahead with supervised tuning. When I say supervised tuning, you give a data set where you have an input and output, and based on that, model can be tuned, which is very, what is it, powerful if you know the output, right? But something like a summarization use case, right, where you don't know the output, right, you have a document and you don't know that what could be the actual summary of this document, right? That's where maybe you don't know, and it cannot fall into the supervised tuning part of it. And hence RLHF, which is reinforcement learning human feed excuse me, human feedback, comes into the picture. which allows you to give a thumbs up and thumbs down, right? So whenever a model is generating a response, you can go ahead and try to do a thumbs up or thumbs down, and based on that, model can try to, what will say, align with that behavior and give you more accurate result, right? Now let's understand the data curation. Okay, so it's very important that you get the right set of the data to the model, right? And if your data, so consider if you are looking for a very specific domain based problem, you need to feed that data so that model can be tuned based on that curated data set, right? So what we are trying to say overall over here is you can go ahead and customize the model via three options: supervised tuning, RLHF, and then if it is a very customized problem or domain specific problem, you might need to tune it with a very specific data set, right? uh, then once you basically have, what will say, customized the model, right, and you did the tuning and distillation and all those, the next thing comes into the artifacts, right? And since we are talking about the LLMs, right, there could be a new additional artifacts which will come into the picture, and those are nothing but, what will say, the tuned job, right, embedding and adapter layer, right? So basically consider if you are trying to tune the model, we have something called as a Vertex AI pipeline. As I said, Vertex AI was already existing end-to-end MLOps platform. Under that, there's a, what will say, offering which is called as Vertex AI pipeline. Vertex AI pipeline allows you to do the end-to-end management of the, what will say, tuning jobs, right? So basically consider if you want to tune and you want to create a pipeline type of structure where you want to feed some data, get the response, what will say, measure that response, and then again retune that model. That's where the Vertex AI pipelines come into the picture. The second part is nothing but a model registry, right? All the different models which you have, right, can be registered onto a single place under under Vertex AI, which is called as model registry. So you could have the AutoML model, custom model, LLM models, everything could be, we'll say, embedded or can be integrated into a single place, which is nothing but a Vertex AI model garden registry, right? The last feature is, now since with LLM embedding is getting very very powerful, right, everyone wants to do the embedding in order to generate a semantic layer on top of your data, and then you want to persist that embedding as well. So as part of Vertex AI feature store, you can go ahead and persist and store that particular embedding, so that maybe whenever you want, you can go ahead and use it, right? So with new artifacts of LLM, Vertex AI existing platform would be capable enough to support these new artifacts, right? Let's move to the maybe next part of it, right? So we talked about the new features, new artifacts. Now let's see the evaluate and monitoring, right? So as I said, it's very difficult to understand that how LLM is behaving, right? And one of the common problem, I think everyone will agree, is hallucination, right? So in order to understand that, whether I can, how I can reduce my hallucination, how I can try to evaluate my model, how I can try to monitor it, right, is something very important. And that is where we have come up with again the three particular, what will say, offering, or three particular features over here, which allows you to evaluate and monitor the generated output from LLM, right? So one of the very important thing is the metrics, right? It's not like a traditional AI model where you are trying to maybe measure the accuracy or try to basically understand what is the precision, what is the recall, what is the F1 score. But you need to understand the metrics which you want to evaluate as a part of LLM. Okay, and then basically try to understand whether you are looking for the accuracy, fluency, factuality of reference, right? Based on that, basically you go ahead and try to evaluate your LLM model. The second very important thing is safety score, right? You want your LLM model to be trustworthy. It should not be, what will say, biased, right? And that is where what we give you is the score of 10 category, right? So if you'll see, we have like a safety score which it will be given by our LLM model as a part of JSON. So whenever you call an API, you get a response as in JSON, and in that you will see the safety scores coming up for all those 10 categories, and you have the option to set up the threshold in order to, what will say, evaluate and monitor your output, right? The last but not the least is recitation check, right? So consider if you have written a prompt and you're getting some response, and if we have a threshold that if the response is coming maybe more than this particular letter or this particular character from this source, we give a recitation link into the output so that you can go ahead and validate that from that particular page, right? And this is again very very important to make sure that it's not basically replicating the existing content at length, right? So these are the three important what is it parameters or evaluating criteria which we try to apply onto the generated output of LLM, right? Going next, right? So we have seen that artifacts, we have seen maybe the different what will say tuning process of the models, right? Supervised, unsupervised, and multiple other stuff, right? Now let's see, as I said, right, most of the enterprise will already have a data, right, which is like their enterprise data. They wanted to connect with the LLM to generate the inferences, right? And that is where the main problem starts, because they are trying to say that, these LLMs are fine, but I want to generate inferences based on my data, and hence I want to connect to my enterprise data set by applying the right, what will say, security, governance, and policies, right? So that is where we have come up, and again it's a Vertex AI property which I'm talking about, and all those features which I have explained is a part of Vertex AI. So if you'll see, right, within Vertex AI we have come up with embedding and vector search, right? So what does it allows is basically, and again it's a very powerful thing which I was just trying today only, that you can go ahead and embed the text and image both the output and try to basically search on top of that. You get a fully managed vector database which has a very very low latency for vector search. And the third very important thing is, consider if you want to integrate with LangChain maybe in order to do certain orchestration, you can go ahead and do that, right? In order to do your enterprise data, right? So because your enterprise data could be of terabytes, right? And then maybe in one go you might not be able to do the embedding of that complete data set, and hence you want to go ahead and do the integration with LangChain in order to basically do the chunking type of thing, and then use that maybe in order to do the vector search, or maybe the what will say embedding it, right? So that is where this functionality of what will say LangChain comes into the picture. The second most important is grounding, right? So whenever a response is generated, right, we try to provide the citation that, this response is coming from maybe this page. And I hope maybe folks onto the meeting, right, you must have seen a product called enterprise search, right? The enterprise search allow you to upload any documents, right? And then maybe you can go ahead and search maybe on top of that document. So it gives you the citation that this particular result is coming from this page, so that you can go and check and validate the response of the enterprise search. And that is what the grounding which I'm talking about. And then the last part is the extension. Basically it allows you to basically what will say connect to the real-time data and real world, right? So this is the complete now end-to-end flow of ML ops, which is scattering to LLM ops now, right? So what we have done is, into the existing ML ops pipeline, we have added few more functionality, few more features, so that it can serve the requirement of your what will say LLM ops as well, right? Now, maybe I will just quickly run maybe in 5 minutes. We have come up with few evaluation and monitoring parameters, which is a very unique things which we have bought very recently, right? So in order to evaluate the output from the LLM model, right? And this is an example which you can see. A model has generated three output, and this is nothing but a summarization example which I have shown over here. How you will understand that which output is the better one, right? And it's very difficult to understand that which output has done, maybe which output is maybe the more impactful, or maybe trying to cover most of the point, right? So in order to do that, right, the and again, as I said, this is one of the very common ask from the customer, that how I can try to understand and solve the evaluation, which is not a solved problem, right? And why it is not a solved problem? Because there are lack of metrics, lack of data, and lack of what will say and there are large what is the decision space. In order to do that, right, what we have solved, right, and how you can try to take that decision, that whether your model is working perfectly or not, is basically you can go ahead and try to what is it select a model from a model garden, where we have maybe hundreds of model, right? Based onto the performance efficiency, you can try to choose a most efficient model, right, and then try to understand and evaluate from the different performance criteria, right. You might need to take a call or trade off between performance and cost, right. Kevin mentioned about the hardware, right. So you might want to basically compare that which model needs what type of hardware, right. But yes, definitely that is something you need to take a call. And then the what will say as I said, right, biasness and safety and security, which is again very important parameter to monitor in order to take a call that okay, whether the model is correct or not, right. And then finally the complete what will say model performance parameters, right. So these are some decision space which maybe you can take into the consideration while evaluating LLM model. I will quickly go ahead and try to talk about these three important building blocks which we have recently come up in order to support the evaluation service, right? And again, this is very unique. Okay, this is very unique proposition which we have bought, right? We have come up with the automatic auto SXX and then safety bias, right? These are the three important features which we have come up in order to what will say which we have come up in order to which we have come in order to what will say try to understand the evaluation service, right. Maybe I will try to quickly show you maybe one slide that how it works, right. So this is nothing but the evaluation matrix skin which is again onto the Vertex AI pipeline side of it, right. So based onto the use case, so in this example if you will see, we are trying to solve the summarization problem, and we see that the output or the matrix which is primarily used for summarization is very low, and hence we can come up with a what will say understanding or a output saying that this model is not behaving what will say up to the mark in order to solve this particular problem, right. Again, since we have limited time, I'm rushing little bit, but maybe you can definitely try to explore these three important features which is primarily around to the evaluation criteria. The second is auto SIS, which is nothing but auto what will say it's a type of A/B testing, right, which is like site by site model. So what you are trying to do is you are trying to compare the performance of two model. So you have model A and model B. You are trying to compare the performance of both the model, which is a type of A/B testing, and try to take maybe one model forward, right. So it's so this technique is primarily used within our Google ecosystem in order to what will say understand the performance and evaluation of the model. So definitely it's a very powerful technique which we generally use in order to basically test the two different model. So again, I have not, maybe I will not go into the detail, but just to show you that here if you show in this screen, there are two parameters. You will see one model is performing 94%, another model is performing little low, and based on that you can take a call. How does it works is two models are getting evaluated by a third model, right, and that is where it comes into the picture, right. This is again it gives you the what will say explanation also that why which model is superior, right. It has complete explanation and which gets stored into a BigQuery table. Okay, so it goes and basically store into a BigQuery table, and it has a complete what will say description that why this model has been selected over others, right. So this is again, as I said, right, this is a technique which is used within Google in order to find out that which model is perfectly working fine, right. So this is again the second feature. The third feature is safety biasness, right. So as I said, you are looking for a trustworthy model rather than maybe a large model, and hence maybe there are multiple parameters you wanted to consider as part of safety. As I said, right, when you call an API, you get a what will say score for multiple different parameters, and based on that you can set up a threshold and then try to measure the accuracy or maybe the evaluation of the model, right. So this is the third thing where you can go ahead and evaluate your model from the safety or trustworthy side of it, right. So again, in order to build your complete ML strategy, right, these are the 4 points I would maybe just iterate and conclude. You do not have to throw your MLOps model, okay, and maybe because you already had a huge investment there, so don't go and directly throw it. Rather, you can go ahead and add some of the unique what is a component which is required, which is primarily focusing onto the generative AI side of it, and all of these components is highlighted in blue, and we have discussed on each of these, right. The third very important thing, right, is start the experimentation of Gen AI with a low, what will say, risk use cases rather than directly going ahead with a very extensive use case. Maybe we always encourage that go slow and try to pick those use cases which are not looking for a very high accuracy, right? And then those use cases can be easily solved. And then the last one, which we have recently launched a product, right, which can help you to assess that where your organization stands from a AI readiness and maturity point of view. If you will scan this, there are 22 questions which you will get, and then with that you will be able to find out that where your organization stands as part of AI maturity, right? And maybe a good start to start your AI journey and LLM journey, right? This is a final what will say sample architecture which has been shown over here. If you will see, the dark blue is nothing but what will say the generative AI or LLM piece of it, right? And then the evaluation and the pipeline model registry feature stores was something which is already existing. And then once basically you try to go ahead and maybe use this functionality, right, you might want to add something like a monitoring and extensions and vector search, right? So again, it's a sample architecture from LLM ML LLM point of view, right? So with that, I think I'm concluding. Maybe I'm good, and I think we are good. These are a few resources I just wanted to cover, right? And maybe you can go ahead and use these resources in order to learn yourself, pick yourself onto the generative AI piece of it, model garden. We have couple of events coming up, right? If you can see onto the deck, right, we have number 15, 16, 21, right? We have multiple events or multiple sessions lined up. I request, if you have not registered, maybe please go ahead and register and try to maybe take the benefit of these sessions. If you have any questions, please go ahead and put it on the chat, and we are happy to take all those questions. I think we are on time.
Great.
Great.
Um, and we've selected a few questions already for the deck here, so we'll go ahead and take a look at those, as well as if you have anything in the chat, feel free to drop it in. Okay, so question number one: without any technical knowledge, can a citizen developer build solutions on Vertex AI? Is there a course that covers Vertex AI for beginners? Great question. We have a ton of resources on this topic. They're all free. So the first place that I would point you to, and it was linked on the previous slide and also dropped in the chat earlier, is cloudskillsboost.google. This is a fantastic resource. We have many courses, including several on Gen AI, that really highlight all the new skills that you need as a developer looking to pull in some of these Gen AI features that you can find in Model Garden. It also has some sort of broader training on other Google Cloud products, so especially if you're new to the Google Cloud ecosystem, it's a great place to get orientation. A couple other resources I would point you to: Quick Labs, which is often embedded in Google Cloud Skills Boost. And then we also have a fantastic YouTube channel, Google Cloud Tech. We have over 1 million followers. Our DevRel team does a fantastic job of putting out weekly videos on AI services. So definitely check that out. And I think we have time for just one more here. This question is, can you fine tune Google's first party models? So this is a great question. And I realize that the terminology around tuning can be quite confusing. I know I've been working in AI ML for over 10 years, and this is something that I get stuck on as well. So generally, when we say the word fine tuning, and the industry hasn't totally coalesced around a shared definition, but when we at Google use it, we mean a tuning in the sense that you're actually modifying the weights and biases of the model. And so basically, when you're fine tuning, you are in effect creating a new model. So for our first party LLMs, we do not offer fine tuning. We offer instead adapter tuning and reinforcement learning from human feedback. So these are different tuning options. Encourage you to read up more or look at Cloud Skills Boost for more information. But they essentially preserve the underlying weights and biases. You're not actually creating a new model. You're just creating an adapter layer on top. The benefit to you as a user, though, is that you get a lot of the benefits that you would expect from fine tuning without the cost of actually having to maintain and update your own model. So this has actually been something that's been really exciting that's happened since the introduction of LLMs. With historical predictive ML models, you really had to fine tune and create new models. And so that was quite expensive and quite difficult for many people to do because they didn't have the right expertise. So these newer tuning options like reinforcement learning from human feedback and adaptive tuning are much lighter weight. The entry point as a developer to get started with those is much lower. So again, definitely check out those learning sources, explore Model Garden, explore Vertex. These are all great places to get started. And with that, I want to thank you guys so much for joining us. On behalf of Murari and myself, this was a great session. We really enjoyed talking to you today about Model Garden, and we look forward to seeing some of the cool things that you built with it.
Yeah, thank you, everyone. Thanks a lot for joining in.